Alright, welcome back guys. Now we're going to look at factorizing x to the n minus y to the n. Now from your knowledge of CXC, you'd have known what is called a difference of two squares. So you'd have known that if you have x squared minus y squared, this would give you x minus y times x plus y. Now the concept is that we can go to higher powers such as cube, the fourth power, and the fifth power using this. But the question is, how do we get this? And we can actually prove that this is true by actually applying long division. So if we say let f of x equal x squared minus y squared, we can also do this by trial and error. So we want to let x be something that when I plug it into this, I would end up with 0. So we're actually applying the method of, we're applying factor theorem, we're applying trial and error. Now clearly we can see what we can let x be. So if I were to say let x equal y, I would have f of y is equal to y squared minus y squared, which is equal to 0. So if x equal y, if y is a root, then I know that x minus y is a factor. And if we have one factor, we can obtain a second factor by doing long division. So we could say x minus y into x squared minus y squared. Applying a concept, we say x into x squared would give me x. X times all of this would give me x squared, and x times minus y would give me a minus xy. And we subtract. Now we know that x squared minus x squared is 0. But what about when I subtract a minus xy? There's no xy up here, so we can think of it as being 0xy. So it would be 0xy minus negative xy, which would give me a positive xy. Then we have minus y squared, so we carry down that minus y squared. So we have x into xy, which would simply, x would cancel with x, leaving me with a positive y. So we have y times all of this, which would be xy minus y squared. Now when I subtract here, notice that my remainder is 0. So we know that f of x is equal to x minus y times x plus y. And that we call it the difference of two squares. But we're going to apply the same concept and see what would happen with the difference of two cubes. Alright, now let us look at our next example. Factorize x cubed minus y cubed. Now in this case, let us say let f of x equal x cubed minus y cubed. Now we can apply the same concept of trial and error. What can we let x equal to? That would give me 0. So let's say let x equal y. I'm going to have f of y equal y cubed minus y cubed. It does work. So I end up with 0. So this tells me that x minus y is a factor. And we did say once we have a factor, we can always find the other factors. So I'm going to have x minus y into x cubed minus y cubed. So we say x into x cubed would be x squared. X squared times all this would give me x cubed minus x squared y. And then we say we subtract. So x cubed minus x cubed is 0 minus y squared. And of course, we don't have an x squared y up here. So we're going to have to carry back down the minus y cubed. But what about this? Just think of it as being 0 x squared y up here. So 0 minus negative x squared y would end up giving you a positive x squared y. I would carry down the minus y cubed. We say x into x squared y would give me a positive xy. And we do the process all over. Xy times x would give me x squared y. But xy times negative y would give me a minus xy squared. and we subtract again. Now we don't have an x squared y up here either, so we think of it as 0. And 0 minus negative xy squared. I should have said xy squared, not x squared y. Xy squared will give me a positive xy squared. And once again, we have to carry on the minus y cubed. Now we say x into xy squared would just be y squared. And y squared times all this would give me xy squared minus y cubed. See, the remainder is 0. So once again, we have an idea that this is correct. So we can say that f of x is equal to x minus y multiplied by x squared plus xy plus y squared. And you might be asking me now, can't x squared plus xy plus y squared go any further? No. This is what is called an irreducible quadratic. It can't be broken down any further. It can't be factorized at this point in time, unless we're going to bring in things like complex numbers, which we don't want at the current moment. Now for my next example, what if I tell you to factorize x to the 4 minus y to the 4? The first concept is that I know that I can look at this as the difference of two squares. What do I mean by that? X to the 4 can be written as x squared by laws of indices minus y squared, which means that when I factorize this, I'm going to have x squared minus y squared times x squared plus y squared. This can further be factorized because x squared minus y squared, also the difference of two squares, would be x minus y times x plus y times x squared plus y squared. And we know that x squared plus y squared can't go any further because that is irreducible. That is one angle to look at it. Now let us look at it as how we were looking at the previous questions, so we can develop a set of patterns. We found out that x squared minus y squared is equal to x minus y times x plus y. We found out that x cubed minus y cubed is equal to, or equivalent, let me say equivalent to, x minus y times x squared plus xy plus y squared. Now can we deduce x to the 4 minus y to the 4? We know it's going to start with x minus y as a pattern. Now look at x cubed minus y cubed. We have the power is x cubed minus the power is cubed, but this starts at squared. Then the x squared counts down to x to the 1, the y comes in, and then the x goes away, and the y goes up to y squared. Now if you look at the powers here of the x and the y, notice in all combination, the sum of the powers is 2. This is just 2, because this is just x by itself squared. But the power of the x in this middle term is 1, and the power of the y is 1. And the power of the y squared over here is 2. Now, notice that 2 is less than what the power of the x cube and the y cube is. So what do we think that this is going to be? Alright, let us say we know we're going to start with x cube. Alright, the x cube is going to count down, and then the y is going to come in. So we're going to move from x cube to x squared y. We count down again, so x becomes x, but the y is counting up, so we're going to end up with a y squared. And then finally, the x will go away, and we end up with a y cubed. Alright, so there's a pattern developing here. Now, where x to the 4 minus y to the 4 is, we could use the concept of the difference of two squares, or this depending on what we want. Now, let us go for x to the 5 minus y to the 5. We know it's going to start with x minus y. Then, of course, we know the next term is going to be 1 less than 5. So you have x to the 4. The x to the 4 counts down to x cubed, and the y comes in. The x cubed now becomes x squared, and the y goes up one more, which gives me y squared. The x goes down to x, and the y moves up to y cubed. And then, of course, the x goes away, and I have y to the 4. And that is me factorizing this, which means I can generalize this thing. So we can generalize it. So let's say we have x to the n minus y to the n. This would be equivalent to we know it's going to start with x minus y. Now my next term, or my first term in the second bracket, will always be 1 less than the power of the x and the y. So I'm going to have x to the n minus 1. Right. It's going to move down to x to the n minus 2. Then y comes in. Then we go to x to the n minus 3. Y goes up to the squared power. Of course, this is going to continue on and on and on, because we don't know what the value of n is until we get to the last set of terms. Now, of course, this thing is actually symmetrical. So whatever happens up here with x will happen down here with the y. Now, what is my third to last term going to be? Let's look at my third term here. What it means is that these power will now become reciprocated. So you're going to have x squared, but y will be raised to n minus 3. The second to last term would become, so x counts down, y counts up. So you're going to have xy to the n minus 2. And then my final term will just be y to the n minus 1. And that's the last term. So this is me generalizing this. Good? Now the question is, what about the sum of cubes? Can I factorize the sum of cubes? We can indeed. We're going to do an example where we do long division first, and then we show you by using the same pattern here. Now let us look at how we would factorize the sum of two squares, x squared plus y squared. Let us start by saying let f of x equal x squared plus y squared. Now I need to let x be something so that when I put it into this expression, I'm going to get 0 so that we can determine what that factor is. If we let x equal negative y, I'm going to have f of negative y is equal to negative y squared plus y squared. So this is going to give me y squared plus y squared, which is equal to 2y squared. Now why isn't this working? The concept here is that if I'm going to raise a negative term to a even number, it is always going to be a positive. So this cannot be factorized in the real number system unless I'm going to venture into a different number system, which is a complex number system. We're currently not looking at that. So when the powers are even and it's a sum, it means that it cannot be factorized. So we can't factorize x squared plus y squared. That is irreducible. We can't factorize x to the 4 plus y to the 4. That is also reducible. And we can continue on and on and on. However, let me just take this out here. Let us say that the power was odd. So let us say we wanted to factorize x cubed plus y cubed. Now, if we call this, let f of x equal x cubed plus y cubed, and we let x equal to negative y, what I would end up with is f of negative y is equal to negative y cubed plus y cubed. The trick to this is that when you raise something negative to an odd power, it is still going to be negative. So you're going to have negative y cubed plus y cubed, which turns out to be 0. Now, what would the factor be? Since we know that x equal negative y is a root and it works, my factor would be x plus y. And I could use x plus y to divide into this and see what happens. So we could even do it by long division. But this time I'm not going to be doing it by long division because there's no need to. I'm going to be doing it by comparison. And this is something we have to know at the CAPE level, how to use comparison to factorize. So we know that x cubed minus y cubed is equivalent to x minus y into x squared plus xy plus y squared. And these are things that you're going to have to know from memory now because these are going to come in various topics. So you have to know them. Now I want x cubed plus y cubed, and I want to apply the same concept. I want to use the difference of 2 cubes to do this. How do I do that? I simply rewrite this expression. So we can write it as x cubed minus negative y cubed. Why can I do that? Because when we have two consecutive minus signs like that, it becomes an addition sign. So it has the same value as saying x cubed plus y cubed. Now by comparison, we have x cubed minus negative y cubed. How does this work by comparison? What it means is that if I'm comparing it to x cubed minus y cubed, in the place of x, up there we have x, which is the same thing down here, but in the place of y, we're going to have a negative y. So on the right hand side, I am going to replace all the y's with negative y. So this is going to become x minus negative y into x squared plus x times negative y plus negative y squared. This breaks down to, and bear in mind that this is really x cubed plus y cubed. This breaks down to x plus y into x squared minus xy plus y squared. So when I factorize x cubed plus y cubed, this is what is going to come out of it. And notice we did that by comparison. So in the place of y, we simply put negative y. And because of that pattern, remember that the powers are odd, or even, odd, even, odd. So there's going to be an alternation. And here's an easy way to remember it. If you have the sum of cubes, look at the signs. You have a positive in the first bracket, the next sign you see is a minus, and then the next sign you see is a positive. So we have kind of an alteration taking place there. Alright, let us look at x cubed plus x to the fifth power plus y to the fifth power. So if I have x to the fifth plus y to the fifth, similarly to x cubed plus y cubed, you start out with an x plus y. So we're going to have x plus y, open bracket, and then we know the term in this starts at the power 1 less than what you have over here, which is 5. So you have x to the 4. Now if I'm using the sign pattern, the next sign will be a minus. Alright, the x goes down to x cubed and the y comes in. So the signs are going to alternate. So you're going to have plus, I'm going to have x squared, y squared, and then of course you have minus plus, so minus again, you have xy cubed, and then finally you're going to have y to the 4. So we can watch the signs carefully to see what actually happens. So these are two very important things, and you're going to have to know them from a conceptual perspective. Notice with the sum of cubes, the power cannot be even, because that would make it irreducible. Alright? Now, can I move to the point where I generalize this? Indeed. So we have x to the n plus y to the n. And the condition is that n must be odd. So this would be x plus y. We start at a power 1 less than the power there. So you have x to the n minus 1. Then it goes down to the x to the n minus 2. The y comes in. No, this wouldn't be plus, sorry. This would be a minus because the signs alternate. So we start with plus in the first bracket. The first sign down there is a minus. Alright? And this of course goes on and on to the second to last term. Now the second to last term will also be a negative. So you're going to have minus x y to the n minus 2, and then the last term will be plus y to the n minus 1. And this makes sense because if n is odd, n minus 1 would be even, and hence you would have raised a negative y to an even power, which is going to make it positive. Now that we have looked at the sum and differences of x to the n plus y to the n, what would happen if you were to get an example to factorize? That's what we're going to be looking at next. Now at this moment we're going to be looking at some examples. And the first one says factorize a x cubed minus 8. Now we know that this is the difference of two cubes because we know that 8 can be written. This can be written as x cubed minus 2 cubed. Now recall the pattern that we're going to be using, that x cubed minus y cubed is equivalent to x minus y. Alright, we know the pattern x squared plus xy plus y squared. So don't mix up the difference of 2 cubes with the sum. Everything is positive in the second bracket when it comes to the difference of 2 cubes. So by comparison, x cubed minus 2 cubed is going to be equal to or equivalent to. Notice in the place of x we have x, but in the place of y we have 2. It's the same thing we translate on the right. So we replace all the y's by 2 and all the x's by x. So we have x minus 2, open bracket, x squared plus xy. Remember y is 2, so you're going to have 2x plus y squared, y is 2, so we're going to have 4. And that's it. In the case of x cubed plus y cubed, so this would be x plus y. Basically the terms are the same, but you have the signs alternating. So we start with a plus in the first bracket. We have x squared and becomes minus xy plus y squared. So when I have, and b, for example b, when I have x cubed plus 2 cubed, the same concept is going to be translated. I'm going to have x plus 2, open bracket, x squared. Bear in mind that x is in the place of x, but in the place of y you have 2. So you have minus x times 2, so minus 2x. And then of course, plus 2 squared, which is 4. So whenever you are given a question to factorize, you can just go back for the general expression, and then you use that to factorize it. You can't go wrong there. Alright, let me create some space here for c. Now, where c is concerned, we did speak about c in several lights. We can start by looking at c as the difference of 2 squares initially, because c can really be dealt with as the difference of 2 squares. Alright, so in this example, I could think of this as difference of 2 squares. So let me just write back everything first. So 16 is really 2 to the 4, and 81 is really 3 to the 4. So I can write this as 2x all to the 4, just to be clear, minus 3y all raised to the 4th power. Now we can further go on and say this is 2x squared to the second power minus 3y squared to the second power. So this can be looked at as a difference of 2 squares. So it means that I'm going to have 2x squared plus 3y squared, and then we can have 2x squared minus 3y squared. Of course, we don't have to go through all of this rigmarole because we know that 2x squared is really 4x squared. Right? But just to show you the concept. And then of course this can be further broken down to 4x squared plus 9y squared. And of course we'll do this because we know where the sum of squares are concerned, that is irreducible. But this can be further factorized. So we have 2x minus 3y, and we have 2x plus 3y. Right? And if we want to make this look more beautiful, we could write these two seemingly linear terms first, then we write the reducible quadratic. Alright, so we could change the order here, but that's not necessarily very important. Now, of course, we know that this can also be factorized using a second method, depending on what the question asks for. So we did the first method, which is to treat it as a difference of 2 squares, but we could also treat it as x to the n. Or we can, so let me just go with x to the 4. I don't want to go back to the entire general thing. X to the 4 minus y to the 4, which we say this is equivalent to x minus y into x cubed. Alright, remember the x counts down and everything here is positive, so you have x squared y plus xy squared plus y cubed. So if you follow the pattern, you don't have to sort it because there's a general pattern developing here. So when you have 2x to the 4 minus 3y to the 4, what it means is that in the place of x, you're going to have 2x, but in the place of y, you're going to have 3y. So we're going to have 2x minus 3y into 2x cubed. So I don't know if you want to initially write it as 2x, bracket that and put cube, plus x squared y. So you have 2x all squared, and y, bear in mind that in the place of y, you have 3y, plus xy squared. So you have 2x times 3y squared plus y cubed, which is 3y cubed. Taking this down, you have 2x minus 3y into 2x cubed would give me 8x cubed plus 2x squared, that would give me 4x squared times 3y. 4 times 3 is 12, so you have 12x squared y plus 2x times 3y squared. Now when I square 3y, I'm going to get 9y. 9y squared, that is. And I multiply that by 2x. So that is going to give me 18x y squared. And then 3y cubed would give me 27y cubed. Alright, so that's one perspective to look at it. Now, as I said, the question will indicate to you whether or not it wants this form. But if we're just told to factorize, we can treat it as a difference of two squares, and then we factorize as in the previous scenario.